going to go ahead and hit record. And, I think we should probably go ahead and get started. If other people trickle in, that's great. Can everybody hear me okay? All right, at least for the video cameras on, I can see some thumbs. Okay, and Mary too. Great. I know our webcam's not working. So I think, first off, welcome. This is our first one. You guys are in at the ground floor. But we were talking, we've already got 70 members that signed up, and we basically just, created this meetup group. And so I think that that's a good sign that I think there's a lot of interest out there in kind of serverless architecture and, just kind of an approach to developing software with like cloud native stuff. And, we or myself, Justin, others, we thought we wanted to create this meetup because, we've been doing serverless for years now. And, we've had a lot of great success. We've been able to build large scale systems really quickly with it, with not a lot of overhead maintenance in terms of managing infrastructure. We've taken other teams inside of our organization that are doing maybe more like traditional development or container-based development and hosting that, and shown them kind of these patterns, and basically the feedback has been really, really positive. And like, we've seen really good, increase in their productivity, their ability. We've got great feedback. So, we thought, well, hey, let's start to create a community around this. Can we share some of the things that we're doing? Are there others out there that are doing it as well? And can we learn things from them? And so that's kind of why we created this, serverless architecture in real life meetup group. Was really to kind of start to have some discussions around it. And we thought we would get it started, by basically presenting some of the stuff, that we've been doing and just kind of scratch the surface. But I do think one of the things that I was thinking about for this meetup group that would be really important is that when we do presentations, that's why I put in real life, because I think it's really nice to like see code and, talk about things that people have done, like have real experience with, versus just kind of like, a presentation about Lambdas or something like that. So that's kind of why I added that in real life thing, is that I'm hoping to kind of curate this in a way that it's kind of real life stuff. We're talking about code. We're looking at, real technical presentations basically around serverless architecture. So that was kind of the intent of creating the group and trying to create a community around it. And our hope is that, we're just kind of seeding it, but that maybe others would like to participate and present, and that we can, get more and more people involved. We actually have two meetup. It's like a network I created. I guess that's how you do it. I have one in San Francisco because I'm based out of the Bay Area. And then, others in our company are like based in New York, but we have a big contingent in Minneapolis. So we also have a meetup in Minneapolis. And so we're thinking that we'd also do some in-person ones in Minneapolis, probably at some point, once we're able to kind of build up a group. We've got an office downtown in the Fifth Street Towers and that type of thing. So without further delay, though, to kind of get into it, I want to introduce Justin Shreve. He's the director of engineering at Sportradar, and he has been so gracious to be our first presenter. He's put together a presentation about, some of what we do at Sportradar, and then also kind of a soup to nuts kind of end-to-end demo of kind of how to put together a serverless stack. And I don't want to steal too much of your material, Justin, so I'll just leave that, let you do your intro and get into the material.
Yeah, thanks. Let me share my screen here. That working?
That is working.
See my slides? Okay.
Yeah.
I'm Justin Shreve, Director of Engineering. I've been with Sportradar for a little over 7 years. Been working on serverless for a good chunk of that, and been doing software development for way longer than I'll mention. A long time. For those of you who don't know, Sportradar is a sports technology company. We provide data feeds. We have analytics. In the US, we focus mostly on data feeds, analytics, and broadcast solutions, insights to sports data. We also, in other countries, focus on betting a little bit. If you're ever watching a baseball game, and you see some stats fly up on the screen, most likely coming from Sportradar. If you ever heard an announcer say something like, no team has ever won back-to-back overtime victories in the playoffs, those types of facts are coming from our software and data that we provide to big enterprise media customers. So to deliver on all that and to do all these solutions across all the different products we provide, we've been focusing a lot on serverless microservice architectures. Kind of the outline for what I was going to go over is, quick introduction to what is serverless, kind of display a little bit of some diagrams of how we've used it in various products and use cases, a little bit about microservices, and then spend the majority of time kind of getting into some code. I have a sample app that I can go over that kind of outlines a mini kind of fake microservice, although something very applicable to what we usually do on a day-to-day basis. So what is serverless? Serverless is, a lot of people think serverless is Lambda functions, like functions as a service. Obviously, AWS is key to this. Sportradar uses AWS a lot. So a lot of what I talk about will be related to cloud data development with AWS. But serverless is basically a way to manage as little as possible and pay for what you use, like on-demand pricing. And it's a cloud native approach to develop software. And you kind of, all of the server maintenance and operating system stuff is usually abstracted away, where you can focus on just building software. One thing, a lot of people think about Lambda functions as being serverless, but it's actually queues and authentication, secrets management, firewalls. AWS has really spent a lot of time making everything available to you. So serverless really just goes beyond just, functions, I guess. So how does Sportradar use serverless? Here's a simple diagram. We do a lot of data loading. So we usually have a lot of sports that we work with. We have to get the sports from the source, obviously various different sources out there. We ingest it, we transform it, ETL basically, put it into S3 buckets, put it into databases. So we run a lot of those through step functions, Lambdas. We use databases in AWS. We also use it, here's another diagram for data loading where we have active game dispatches. We'll actually have serverless functions on a schedule that watch schedules. And when a schedule changes from pending, scheduled to live, triggers a whole other sequence of events. Another whole process for data loading happens. And again, it goes in through various Lambdas, into S3 buckets, into queues, and drops into databases. We also use it for authentication. We'll have, API Gateway, which is a serverless API that AWS offers. We can tie that into Cognito and do authentication and authorization through some of the different mechanisms that they provide within their ecosystem. A lot of our REST APIs and GraphQL APIs are all based on serverless as well. So we'll have various forms of API Gateway sitting in front of Lambdas, and then they'll connect to databases, do simple CRUD, return your post, return your GET. We're going to get into a lot of that in my sample app today. And the last example here is just deployment pipelines. So a lot of times we use GitLab for some of our repos. We'll have our normal CI/CD pipeline set up in there, and then we'll trigger a deployment pipeline inside of AWS. We'll use EventBridge, we use Code Deploy, we use CloudFormation to migrate code, deploy code, roll back things, potentially run canary deployments. So we kind of really leverage the serverless ecosystem for deploying code as well. Microservices, this is kind of just in general microservice pitch. We find that the separations of concerns makes it a lot easier to deploy enterprise level software. It's easier to test. You can actually, when you isolate services, you can actually do documentation a lot more concisely and directly. You get, if it's orchestrated right, you get nice operational consistency across projects. What we found was that serverless and really helped. The most challenging part of serverless or microservices can usually be, all of the different microservices. How do you pull them together? How do you deploy them? How do they talk to each other? Well, we found that serverless is a great way to kind of orchestrate that, and the architecture will, when you leverage CloudFormation, Code Build, and Serverless Framework, which are some of the tools we'll go into soon, they really make the whole microservice architecture, it really clicks And it actually almost eliminates almost all the need for DevOps, because developers can be in control of, I need a queue, or I need to spin up a database. And they can kind of make the changes, infrastructure as code, deploy it, and see the progress right away. Here's a quick slide on, just a simple, here's how we kind of broke out in one of our products at Sportradar. Microservices, you can see we've got like some setup resources, we've got a lot of data pipelines, and even the data pipelines are broken down into numerous microservices. And then we've got app microservices. We have microservices for users and league data and configuration and ranking reports and all types of different things. Again, just going back to separation of concerns. So getting into the sample app I was going to go over in kind of the remainder of the meetup here, we can get into the code and deploy it and see how it works. Well, basically, what we usually see in a lot of different areas within the company, we have, like I mentioned, we have some source data. We need to pull that into a system, store it into a database. And then sometimes we need to add to it. So we might get players in one database, and then we might get stats coming into another database. And oftentimes in normal ETL environment, you like merge the things together and then potentially create a data feed, or you'd create other types of output. So the sample app, I have 2 microservices to kind of demonstrate all of this. The one will just be a player service. So we'll have we'll post some players to it, save it into a DynamoDB, and then we'll also have a get interface so we can get those players out. So basically simple CRUD on the player service. To pull that together, we'll go into a stat service as well. And that stat service will kind of create some fake stats in this example, but basically pull player data, add the stats, and then create a sample feed that will then be able to see as the output, the final output. So it'll kind of look like, I have a diagram here like this. So here's the player service. We're going to have a get endpoint, just to get the items. And then we're going to have the post endpoint, which will save it to Dynamo. So this line here will kind of be our separation. We have the players on one side and we have the stat service on the other side. On the other side, we're going to use a step function. So we're going to end up just triggering a step function, which will then do some discovery, go grab our players, process each player individually. So we'll have a kind of a workflow here where we can say, okay, here's player A, let's add his stats. And then once those are all done, we're going to use a last Lambda to merge the results from all the player stats and create the feed. And this is a little oversimplified for what we normally do, but it should make, it should help hopefully put this all together in context for everybody. So let's get started here. Hide that. So here I have Visual Studio Code. Can everybody see this okay? Yep, all right. So I basically just have 2 folders like I just kind of talked about. I got the player service and the stat service. Anybody feel free to interrupt, obviously, have any questions if I'm going too fast or anything like that. I'll just keep rambling on here. So the player service, if I open this up, I have kind of, a normal, I just want to let everybody absorb the directory here. The serverless folder and the coverage, these are actually from running some tests. So they're kind of irrelevant in the folder structure right now. We'll get into what the Lambda folder has here, which is basically our get and post endpoints, kind of our controllers. Node modules is, if anybody's familiar, this is a Node.js project using TypeScript. Node modules is going to be our dependency folder created by running npm install. And then the source folder here is going to have most of the real code, like the majority of the real code. And then we've got some Docker Compose files here for testing. This is just our output of our tests. This is a configuration to spin up DynamoDB locally so we can run some integration tests on our storing data. Package.json file, if you're familiar with Node.js, this is where you define all your dependencies, some of your testing, some of your testing configurations, and then some of your commands for running the tests, pre-tests, post-tests, cleanup, things like that. This one's a little bit more complicated than normal because it is integrating with DynamoDB. And then we're going to get to serverless YAML. This is where actually a lot of it comes together. And this is how we'll orchestrate all of the services. It's our infrastructure as code file. This is where we're going to say, okay, I have all these Lambdas and I want to use DynamoDB, and this is how it's all going to work together. So that's kind of a quick summary. Hopefully everybody can kind of digest these folder structure. Again, it's like, our source is going to have the majority of the real code. The Lambdas, I can show you these are very lightweight, the kind of the controllers. So when we invoke a Lambda, it'll basically be invoking this function first. And most of the time we try to keep these really lightweight. It's just like the interface. So you see it'll get an event, do a little bit of error checking, and then call the code that's in our source file. Same with the post, very lightweight kind of controller. And then we have some tests here, basically just, you know, testing simple stuff with the validations. So in this example, I put all the code in players here. So I do have my get function and my create function. You can kind of see they're all in the same file here. Obviously, if this was bigger and there was more logic, we might want to split this out. But for this example, kind of put it all in one file here. So we've got some DynamoDB commit, you know, libraries here. The DynamoDB library is basically just helping with the connection to Dynamo. And here I'm getting my DynamoDB table. I'll cover list when we look at the serverless file, because the serverless file is going to spin up DynamoDB, create the indexes, and then expose this environmental variable DynamoDB. So when I'm working through this, I never really care what that table name is, except when I'm writing my serverless file, but it's kind of injected into the code automatically here. So I don't have to worry about like, what is the table again? It should just mostly work in this instance here. I have an error here in case, you know, our get is failing. And then in TypeScript, I'm just defining my player, very simple player interface here. So you can see the create function will take the ID, the team ID, and the full name of the player, create a player, and basically just insert that into DynamoDB. This is very simple. Probably want to put more validation on this, and then it just returns true here. So we might want to actually get it out and return it as well. So I just kept this very lightweight and simple. And then the get function will take in a team ID. So this get is basically, I'm going to get players per team. And you'll see how that ties into the other example. I just left it at team ID right here. Obviously, again, you might want to build this out and say, okay, I want to get players by specific ID. Give me one player. Give me a list of players by team ID. So this might be, you know, there might be multiple functions in here based on how to retrieve players. And here I'm just creating a DynamoDB query using an index here and saying I want all the data. Limits to 20 for this example, that's fine. And then I get the players and I map them to the player interface and then just return them. So hopefully that's all making sense. So actually right over here, I'm going to deploy this now as I get into some of the other features here. So I've got, this is a normal way to deploy if you're not familiar with serverless framework. Serverless framework is different than serverless. Serverless is kind of a concept of cloud native infrastructure. Serverless framework is actually a library that enables you to quickly configure serverless infrastructure. So the serverless library, you know, the abbreviation for it is SLS here. But if you ever go to, I think if you just do Google for serverless library, it's pretty powerful. What serverless library does is it actually provides a lot of shortcuts and configuration to like spin up serverless services. Behind the scenes, it's creating a big CloudFormation template. So when you configure serverless, you run serverless deploy like I have here, it'll actually zip up your code. And in this case, since I'm TypeScript, it'll actually transpile it, creates a zip file, and then it'll upload that to S3. And then it'll trigger another command to actually deploy that S3 asset into Lambdas. And then it'll also do the configuration for memory and all the other stuff that I'll show you in a second here. So I'll kick this off now. Another thing to point out here is that I'm using -S is for stage. When we deploy this stuff, we're always deploying to stages. And the way that we've set this up as Sportradar is JGS are my initials. So I usually just say, okay, we're all going to go by initials. So all of the assets in our account are going to be tagged and kind of labeled with JGS, which is my initials. So when I go in and I see other developers, I know, okay, all the JGS stuff is mine. You know, all the other initials are obviously other people's code. But it's a nice way to break up all of my things with other developers' things. And then for prod, it's just prod. So it actually translates over to prod. We usually separate accounts in that situation where we'll have prod in one account and all of the other non-prod in a separate account. But you could combine it into one account. It's pretty flexible on how you want to structure all that stuff. And then you have to specify the region, and you do have to specify this is using a default AWS credentials, but obviously this is tied to AWS credentials. I've already logged in and I have these in my credentials file. So if I kick this off, you'll see that it's gonna do what I just said, like the ES transpiling the TypeScript, zipping it up there, and start the upload process. So as that's going to go, it usually takes a little time. This is brand new. I have nothing in the AWS account here. You can see there's no Lambdas. So in a few seconds, they will start to appear in here as they create. But I can kind of show you now the serverless file here. So this is really where you configure everything. And this is what's deploying now to AWS. So I basically just have the name up here. Serverless is also nice because it has a lot of plugins, and these plugins let you quickly add a lot of good functionality with very minimal like additional configuration. So we often use this AWS Alerts plugin. This gives us like alerting for all of our Lambdas. So when the Lambdas start to fail or there's an issue with a Lambda, we get the alerts. We usually pipe them to Slack. And we know about these things really, really quickly. And you can configure the alerts. So you can say, oh, if we get 1 or 2 alerts on one Lambda, maybe that's acceptable. But like if it goes over our threshold, then let us know. You can also configure alerts on duration. If this Lambda is supposed to execute in 300 milliseconds, and it starts to average 500 or a second, okay, now alert and let me know about that as well. So this alerts plugin really helps us here. And you can see here's how like we normally configure our alerts. We usually just do the alerting on prod. It can get pretty noisy if you add alerting to the other environments. You can set up an SNS topic and you can kind of override. You actually don't need all this configuration. It does have a standard version of this, but we kind of override a little bit here to say, we want this threshold, we want these periods, we want these like, all the different configurations for the alerts right here. So this is kind of our standard alarms configuration. The other one that we have here is ES build. This is really nice because I can just drop in this code, this block here, and this basically tells when I type SLS deploy that it'll actually do the transpiling. And I don't even have to worry about like, you know, transpiling that, putting it in a different folder and uploading the wrong thing. It's a really nice plugin to just kind of deploy TypeScript to your Lambdas if you're using Node.js. So down here is the provider. Serverless works with a lot of providers. We mostly just use AWS. So I'm just saying, okay, let's just stick with AWS, Node.js runtime. And then the stage, this is important again, because this will be my initials that I just typed in here. And you can see the stage shows up in all the resources once deployed. And I can show you this now that it's deployed. You'll see the stage name. So when I'm in here, I could usually for us, we see like thousands of Lambdas in here. So it's really nice to just be able to say, okay, where are my Lambdas? And then you can version, log retention. These are kind of just a lot of options. Once you spin up a Lambda, it is always role based. So you do need to define if it has to access any other AWS resources. We're using DynamoDB here. So you can see I've added some permissions to access DynamoDB. And I've explicitly said you can access the DynamoDB table we're creating in this file and the indexes that we're going to create. So this creates a very strict isolation. If another developer spins up DynamoDB, this Lambda will not be able to talk to that developer's DynamoDB, and especially any other account or anything like that. So we're being pretty strict on our permissioning here, which is actually pretty nice and really enforces the separation of concerns. The deployment bucket, this is where we send the zip file. So once we run SLS deploy, it zips it up, it'll send it to this bucket. This is the one thing that needs to be configured beforehand. I actually created this bucket before the meetup, but that was the only thing I actually created in our account before I started this. I just actually created this service as I ran that command. But other than that, there was nothing else created. There might be VPCs. This example doesn't include a VPC. We normally use VPCs at Sportradar, so there is that process of setting up potentially VPCs, and you probably want to create one VPC and add all your projects to it. That would be a configuration in line here. I'm not doing that for this example because it does add a little bit of overhead and complexity, but you can configure that here as well. And here's where you specify your environment. We usually drop in the stage name, which would be my initials, and the service name, which is player service. And here I'm defining the DynamoDB table. As you remember in my demo over here at the very top, actually it was, yeah, right here is where you can access the DynamoDB table. And if I go back to my serverless file, you can see this is where I'm setting it as an environment, and it is referencing DynamoDB table, which I'll show you in a second is created in this file as well. So you can create things and reference them, which makes it really easy for the discovery of what you need here. You know, a lot of times in development, you create something and everyone's like, what's the name of that? Where's the region? All that. And you got to pass around these strings. This was really nice because it kind of eliminates the need for any of that. Serverless offers package patterns. This is nice because lambdas usually execute fastest when they're as small as possible. So you really don't want to upload into upload the lambda with libraries and tests that aren't needed in production when you're actually executing the lambda in a real environment. So this just says, okay, don't include any of these common libraries, tests and outputs that aren't really relevant when you're running it. So here's our Lambda functions under the function sections. We've got the player post and the player get. I've separated these two. There's a whole art form to how to like structure your Lambdas. You can actually do different API entries per Lambda. You can combine things here and there. For this demo, I have a Lambdas post, which goes to its own controller, and I have Lambdas get, which goes to its own controller, as I kind of showed you when I walked through the code up here in the Lambdas folder. I've configured the memory size. You can kind of, you know, if you realize this Lambda is running slow, you would just bump it here, say, okay, let's give it a little bit more memory, which is also tied to CPU. So that gets it going a little bit faster. I have the timeout at 10 seconds, which is probably really high for this. You can go up to 30 seconds is the max for a Lambda, but you can adjust that here as well. And then here is the really nice part about serverless framework is I just add an event and I'm adding an HTTP API. So this is a API gateway version 2, kind of a lightweight REST endpoint option that they have. And all I'm doing here, you can see how easy the configuration. I want to post endpoint and I want it to be /players. And if you can see over here, it created that URL right here. It created the endpoint right here, and then this added players is actually in the code where I can just post to /players to post a player. The nice thing about this, 4 lines is going to create CloudWatch log groups. It's going to set up all the permissioning for me. It's going to set up the API gateway. It's going to map the API gateway to the Lambda. It does all of that with these 4 lines, which is really nice. If you were to look at the CloudFormation template underneath this, after I ran SLS deploy, it's pretty robust what it just did with these 4 lines. And basically did the same thing down here, but switched it to get. And then the final piece under resources, the nice thing about the serverless libraries and resources, you can kind of just go into CloudFormation land directly. So these aren't shortcuts anymore. This is actually straight up CloudFormation code. So I'm saying I want a DynamoDB table. I've set up some indexes here and a global secondary index to kind of search by teams. And this is a very simple configuration for DynamoDB for the demo, but it's really nice that you can just drop in your Aurora RDS here, or your DynamoDB, or your DocumentDB, whatever type of data store you need, or your queues or anything else. You can put that all under resources here. So if I grab this endpoint here, let me copy that. Should be able to post a player. I'm going to get post. This is an old one I had, so drop in the new one, /players, and I've got a fake Parv. Hopefully this works. Post him in there, and I got true, so it worked. I'll add another one here. All right, I got another one. So now I can come over to my get endpoint. You can see this is just a get. I'm just switching. I got to drop in the new URL that I got when I deployed. And I got /players, and I said team ID XYZ, which is what I just inserted on the other side there. Do a get, and there they are. So it's working. Is that clicking for everybody? All right. So now we've got that one side of the service set up. We've got the player service working. We were able to post. We were able to get some players out of it. So the next part of it, I'm going to close the player service. Let's go into the stat service here. So very similar setup. This is going to look familiar. We've got Lambdas. We've got the source directory. I've got my package JSON, my serverless file. Most of the time, well, what I'll get into most here is the serverless. maybe I can switch over here now. I'm going to go down to the stat service. Normally to deploy this, you would just run npm install. I've already done this, so this should be pretty quick. I'm not sure how many of you are familiar with Node, but this is standard Node.js development practices. So got my Node modules installed. I can run npm test. Oops. I can run my tests. This project has some tests on those 3 files. So I get my output there. And then to deploy it, I will do the same command as before. And I'm going to use my same stage. It's exactly the same command that I used to deploy the first service. And that's really nice about all these microservices. And that's how I told you that serverless kind of pulls it together, because you can jump from one microservice to the other, and it's exactly the same. It's exactly the same deployment thing. So I just hit this one, and now I'm deploying the stat service. So I can quickly go through, the lambdas again are going to be super lightweight. You can see it just grabs the event. My TypeScript here is a little loose. I'm grabbing the event any, and I'm just piping it into the add stats. You might want to, AWS does support the events explicitly, so I should be able to grab the API gateway proxy handler event. I should have kind of ironed that out beforehand. But basically basically takes the input. Here I'm grabbing the team ID, and I'm just going to do a call here. So a little bit more here. And then the code here is very simple. I've got a player model. I'm doing a bunch of fake stats for the demo, but ideally here, we'd probably get the player. We would do another fetch to another service for stats. We end up putting things together and producing a real stats feed. Create output is going to take some of the stuff. I'm actually going to aggregate some stats here. So I've got all my player stats that I created in a fake way. I'm going to then aggregate them at the team level. So I have the feed up here, which is going to have team ID touchdowns. The feed is actually the team feed. So it'll have an aggregated stats here. And then the get players this is where I'm just doing a simple fetch. I'm using node fetch here. I'm going to actually go over to the other service, pull the players, and I'm going to go through the front door, which is the API gateway. Ideally, I'd put a key in here, and we'd have like application to application authentication. This example is wide open, but I'm going to go through the front door of the other microservice, get the players, pull them over, and then start to do my processing. So again, a lot of this happens in the serverless file. So I kind of like went through that stuff a little bit quicker to get to the serverless file here. Again, we just got the stat service. This one's we have added one more plugin here, which is step functions. And I'm going to get into the full step function details down below, and then I'm going to execute that and show you how that works. But step functions are really great to orchestrate a lot of lambdas, because the lambdas are just going to be a function. So it's going to do one thing. You really don't want to overload that, and you want to keep it small and very efficient. So the first thing that usually happens with serverless development is you say, well, I've got a lot of things to do here. How am I going to orchestrate all this stuff? And then you start to look at queues, and you're like, okay, I can queue this stuff, but then I want to do this and that and this and that. And my Lambda gets to be huge. It's harder to debug. It's harder to deploy. So then you start breaking it down. And you're like, okay, I want this Lambda to fetch players. And then the other one is going to inject stats. And then the other one's going to compile the feed. So you start to break it up into smaller functions that are doing more explicit things that are easier to test. And then you can pull them together nicely and orchestrate the flow of logic using a step function. So the top here, this is exactly the same as the other project. The ES build, our alerts, the alarms, and then we're doing our standard Node.js, AWS, log retention, deployment bucket. So one of the big differences right here is our player service. So here I'm just using a CloudFormation variable syntax to go to the player service for my stage. So this is going to reach into my JGS stage for the player service and get the endpoint. So again, I don't need to know if you looked over at the example output, the endpoint is actually kind of cryptic. Let's scroll back up here. You can create more domain-driven endpoints here, but this one is like EA stuff. So I really don't want to remember that. And I actually don't need to because, well, I did for Postman, so I needed it for the demo. But for this service, I don't really care about taking that and like pasting it in. I'm just going to put this is going to grab it dynamically and set it as an environmental variable that I'll then use to make the request. And this is great because if another developer spins it up, they're going to get a different endpoint. Again, no configuration needed there. We kind of discovered the player service, injected it into the stat service, and everything works nicely together. This does create a hard dependency on the player service. I would not be able to deploy the stat service without first deploying the player service. And orchestrating deployments is maybe a whole other meetup that we can do at some point. Again, there's some like package patterns here to just remove all this stuff. And then here's my function. So these are obviously different. You can see I have no event here. There's no event for the endpoints, because these are all going to be just running kind of as a back end job. Like I don't need these exposed anywhere. So they're not exposed at all. Get players, it's just very simple. Just saying, I want to get players lambda, I want to add stats lambda, and I want to create output lambda. And it maps them to the individual files as I went over already. And then the biggest unique thing about this service is the step function. So this is how the plugin needs to be configured. And this plugin is very powerful. You can do all kinds of great stuff in here. And this includes all kinds of great functionality that you can use when you're developing serverless. So there's actually two kinds of step functions. There's Express and Standard. Standard is way better to demo, but Express is cheaper and actually pretty nice to use in most of the situations. I think Express is actually a little bit better. For the demo, I picked Standard. And then you just have a definition. And these definitions are actually really documented well by AWS. They show what you can do here. And with the step function, you can do things like, oh, I just want this one to go to this one to go to this one. That's a very simple flow. Or you could say, I want this one to fan out and I want all of these to go in parallel and come back. And then, that's kind of what I'm going to show you here. You can also do step functions can call other step functions. Step functions can actually call more than lambdas. They can actually go to a queue. You can say, I want this lambda to then map to a queue, and then I want the other lambda to pull off that queue. So you can kind of orchestrate not just lambdas, but you can orchestrate all kinds of AWS services through step functions. A lot of how we do deployments is orchestrating code builds through step functions, but you can, like I said, you can orchestrate queues and lambdas, code builds, I think many other services through step functions. So this one is basically saying, first I'm going to get players. I'm going to start at get players. Here's my states. I'm going to get players. This is a task, and it's actually a lambda. It's going to call this lambda. The timeout here is 30 seconds, which is a little bit off because the timeout up here is 10 seconds. So probably want to do 10 there. And then I'm going to say, hypothetically, maybe my feed goes down for a little bit. So to create a lot more durability, I'm going to say, okay, I want to retry this. Like if it fails, wait a little bit and then try again. And then after in this configuration, I'm saying after two times, I want you to just quit. We'll throw an error. We'll look into it. But you can configure this obviously with any of the errors and configure the back off rate, the temps, and all of this, which is really nice to build more durable enterprise level microservices. And then, it's pretty readable here. Next step is going to go to add stats loop, which is right here. This step is a map step. So I'm going to take all the players that I'm going to pull off the other service, and I'm going to use at two at a time, I'm going to add stats. So I'm going to take two players, I'm going to add their stats, and then two more and add their stats. And this is going to map through all of those. So my lambda add stats is going to take a player, a single player, add the stats, and just return. So it's a nice lambda because you're like, oh, I don't have to worry about the array there. The array is actually handled in the step function configuration here. This is basically saying, look into the object output from the previous lambda and pull the player's array. And then we're going to use that as the iterator here. And then the iterator can be a whole sequence of lambdas as well. Here, this is just one. So it's going to say, I'm going to start to add stats. And again, it's just add stats, which is a single lambda. It has the timeout, which again is wrong, 10 seconds. Again, it has retry. So if add stats is having issues, okay, you can retry there too a few times. And then we're going to go to done looping. This is just a pass state, which just says, okay, we're done with our loop. We're going to go to the final state here. Next, create output, which is create output. You can see it's very easy to read. And then this is just going to execute that last lambda. So we already deployed this. We've got all the functions here. So if I go over to the step functions, hit refresh, there it is. It's never been run before. And this is great in the console for AWS. You can test these very easily. Ideally for this, like in a real production environment, we'd probably have a trigger that ran this. So we want this to run every minute. We want to look for new stats. Or maybe once a night, we're looking for corrections. We're going to run this once a night. It's going to kick off a job. It's going to go look for stat corrections, update everything. Or if it's a live game, it's getting events constantly and it's running all the time. So there's a lot of ways to trigger this Lambda. We haven't gone into that. I haven't configured that here. I'm just going to run it manually. You kind of get the idea, but usually we have a trigger. So when you basically just provide the input here. And as you remember, we were looking for team ID, and XYZ was our team ID for the test here. You can create a name here. They usually just give you a UUID to put and do the start execution. And then this is a nice visual interface that you get here. So here's my step function running. It's getting the players. And then it quickly added the stats loop and all the stats. And the step function, this is for the standard step function. The express step functions do not include this nice UI. So you kind of have to decide how valuable it is to, maybe we often start off in development with standard. And then once we iron through the flows here, we might revert back to express, and then you can just get the logs through CloudWatch. But this makes it really easy to debug. It gives you this nice thing. So I can look at get players. I provided the input here, and it gave me the output of our 2 players that we sent in earlier. And then here you can see how there's a bunch of boxes here. This is the iteration loop. So you can see it went through twice, right? Because we only had 2 players, 0 and 1. And for each one, you can see the input output change over here. And then I added the stats. So you can see this is the input here, and then here's the stats that were added. And then the output of this whole thing, if I go to create output, was basically just an array of players with their stats. This is the top part. So that was output. It basically took all of the individual lambdas and put them into an array. So the output got put into an array, which was passed to the next lambda. I'm not sure you'll get that. It's a little bit tricky, but basically we ran through a loop. The output from each one of those was then put into an array to be passed down to create output. So I'll just repeat that. And then you can see that right here. This was the output of the above one, which is the input of the next one, obviously, because they're going in sequence. So then finally, you can see I've got my team ID and I do the aggregates. Like no touchdowns. That's odd. Passing yards, you can see these are just random numbers, but then it aggregated it up here. So I can see here's my team stats, here's my player stats, and we get the output that we were actually looking for. You can run this a bunch of times, especially since it's not doing anything real. So if I run it again, you'll see, the random stats again. The nice thing here too is if one of these does fail, you can see the key down here. You'll see this red, and you can click this and you can go into exceptions. You can quickly debug these as well, which is really nice. And then down below, you can actually see the event view and go into the different lambdas that were all executed and drop into CloudWatch, look at the lambda configuration. It's a nice way to kind of start debugging something here. It really lets you dig in and isolate where the problems might be. But you can see here again, touchdowns were 2. If I go to the output, I should have a different. Now I've got 3 touchdowns. So yeah, that's about it. I give you my last slide here. Again, I'm Justin Shreve. Feel free to reach out. My email is on the screen here. Love talking about this stuff, and that's all I got right now.
Well, Justin, thank you so much for putting together that presentation and for, kind of kicking off our new serverless architecture meetup group. We thought it'd be a really good idea to show something real and show code, and that is not easy to try to jam that into 40 minutes. So really appreciate you boiling it down. And I know that it just scratches the surface of what we do, right? We're at an enterprise level, but it does show you really how simple it is to say, your code doesn't really change. Your source code doesn't change. How you build software doesn't change. How you deploy that software, how you manage that software, how all of what you need. And I always think of these Lambda functions as the lightest weight container there is. It's just a function container, right? And then having the serverless framework or to tie all this stuff together, and then you don't have to manage any infrastructure. It's something that we've, like I said in the beginning of this meetup, we just found a lot of success with, and we really have enjoyed. And so maybe, maybe what we could do here is stick around for any Q&A, and then also just if anybody is interested in, talking or presenting or anything like that, please reach out to me as well, because I'm going to be trying to put on regular meetups, and trying to get different people involved, and we can keep sharing some of the stuff we're doing at Sportradar. We're always open to talking. So if you guys are interested in what we're doing, reach out to Justin, reach out to myself, and we can tell you more about what we're doing here. But I'd love to also hear what other people are doing and get some presentations going and get a community going and that type of thing. So maybe we get some feedback from the group here on what you guys think of the first meetup, and then 2 QAs and Q&A, and if not, maybe we'll see you next time. So any questions, any thoughts, any conversation you guys want to have post presentation?
Yeah, I'll just say, I know nothing really about serverless. I've never actually done it. I just know of it vaguely. And I think to your point, Michael, the way that you were able to boil that down to something that's actually usable, but also super simple, was really well done. So thank you.
And Justin, I think you could probably make this source code available as well. So we could post the recording and the project, to be able to go back, because obviously it's a lot of info pretty quick, and, and you had to do a little bit of a baking show kind of thing because it's only 40 minutes. And so we can post those 2 things on the meetup group too.
Yeah, I'll post them. I'll put the link to the repos. It should be, you could deploy this to any AWS account. You just need the credentials. And like I said, just create a bucket. You might have to change where the bucket is on each of the projects, and then it should just deploy right away to any account, as long as the user does have access to, Lambda, DynamoDB, and the AWS account ID.
Yeah, any other questions about what was just presented, or any topics?
So I joined a little late. I see this is being recorded. Where's the recording going to be posted?
On the meetup group. So probably post that out on the meetup group. I'll probably have to download it and host it somewhere outside of Zoom. I'll figure it out, but on the meetup group.
Yeah.
I have a quick question around testing, or testing after you've developed a feature for serverless service. Do you typically have a sandbox on AWS, or is that something that your team can do locally?
So usually, because a lot of this with the function, we usually just start with unit testing the function. It's it's very easy. You're basically just testing the inputs, the outputs. You test the source code, did it get what it wants? So we start off with a unit test. We usually run those locally. So we'll start there, and then yes, we'll deploy to a sandbox. So we usually have like you saw when I typed in JGS, that's obviously not production. So I usually deploy that to my own scoped sandbox within an AWS kind of non-prod account. There's where we'll test it. So then I'll execute the Lambda. I'll do the API. You can exercise it infinitely there. And then that's usually when we say that, okay, that's great. I've tested it locally, tests are all passing, put that into the CI environment. Here's an example. If you want to test it, we might get product involved and say, hey, check out my sandbox. Everything's working. And sometimes that's across multiple microservices as well. I might put up, like I did in this example, put up both microservices and say, this is a, two merge request, pull request project. They're both here. They're both testable in one place, and they're working together by kind of, well, in this example, running the step function tests everything. So yeah, we'll do the sandbox, and then usually tie that into the review process. When we get approvals, we'll then merge that to prod, and it deploys exactly the same way.
Yeah, it is a really good question, though, because as we brought it across different teams, a lot of people that were used to being able to run the whole environment locally and everything, there are pieces that really, you do deploy some of this to AWS. You get that everything's based inside of that stage, but you get your own environment. It's deployed just like production. You get everything there. So it's actually worked out really nicely that you have those ephemeral stage environments And yeah, like Justin said, you could deploy a branch off of one microservice, a branch off another, and then get an MR on those two and have them tested. So yeah. What a question that came up here, I think certain stages, what kind of challenges have you faced scaling this up to an enterprise level? Justin, do you want to take it first?
Yeah, I'm not quite sure what that's implying. Obviously, there's a lot of things there. There could be like number of requests to like an API endpoint. It could be, as I kind of covered, like durability and consistency and alerting of like a pipeline. You can see how a lot of that's built in there and is enterprise level. When you deploy like our data pipeline that's ingesting stats, we get all kinds of metrics on that. We get all kinds of, it scales really well because Lambdas will just fan out. So depending on, mostly we end up with database constraints because the throughput of the Lambdas and the API gateway are just not going to be limiting factors. So it ended up on like, how much can one database take? That's where the limits will happen. And that's kind of a typical scaling scenario for any enterprise level software. But again, going back to the pipelines, the alerting and the kind of monitoring of those step functions when we're doing any kind of ingest, and the durability of all the retries is like really, really nice for an enterprise. So I guess, I'm not quite sure what that question was maybe, focusing on, but yeah.
Yeah, I could add to that too. I think the thing that you find most is tuning the like max concurrency rates, the back pressure, those types of things. You kind of tune that up. And so if you have like a queue and then you have Lambdas at the end of that queue, maybe you have like a max concurrency. So you're only doing a certain amount at a time. So it only puts so much pressure, things like that. But then the overall scale is there. One thing that, like with our API product, one of the things that, like we get a lot of requests for data, for sports data. Cost can be a consideration sometimes, thinking about, well, how much of that traffic is actually making it to my API gateway, because my API gateway, it's an expensive call. And so, okay, let me put CloudFront in front of that to offload that. So costs at an enterprise scale, you do have to think about it. But at the same time, we've found that the total cost of ownership for not having to manage infrastructure and the speed that we can get it out, and if we get that set up right, that ultimately that it makes sense for us. It typically makes sense for us. So cost maybe is another thing to just make sure you tune correctly. Was there anything specific from an enterprise standpoint, or did that answer the question? Oh, cool. I see a thanks. Any other questions or topics?
Yeah, I've got a question. Like, is there anything like, this is going to be very vague. Is there any sort of challenges you face with not having some of that control over like more of the server? Like, I know you mentioned one of the benefits is that you have less to worry about, but I'd imagine there might be some scenario, or is it more of like, since you've moved your mindset over to this, those just aren't in considerations?
Yeah, I think the challenges there's different challenges. Like I think Mike was just mentioning, like the concurrency of like, because if you put a Lambda out there and you get 10,000 concurrent requests, it's going to be a problem. So you need to then figure out what knobs to turn. So you're not really, you're in a different context. You're not in the server context. You're now in the serverless context. And there's lots of ways. You like look at the caching strategies, you look at reserve concurrencies, you look at like, what's the database behind it? Are they going to scale? So it's kind of a different set of knobs to turn than when you're on the server. But I mean, personally, I like to do those because they're more directly applicable versus like potentially the server configurations, I don't know. I've done a lot of that as well. It's a little bit nicer to see, you can also do it in real time. You're like, oh, I'm going to change this, caching, change the TTL, just go in and do it right. Potentially, we do most of it infrastructure as code and deploy it through a pipeline, but in emergency situations, you can go right in and make some of these changes right in the console there, which is nice.
Yeah, the only thing I could add is that, like any application that you maybe aren't like, you're not SSHing into a box and, like kind of, managing. So logging and doing good logs and like having a good process for that, I think, and having a good protocol for that, I think really gives you the visibility that you need. Because I think you do deploy it, it's into an environment and it's like, well, what's going on in there? All right, well, if I have good log discipline and I have good ability to look at those logs, that helps a lot too.
Yeah. CloudWatch can be tough to manage, but it can also be very powerful. And, like if you're running, say you have to run 5 servers to scale an application. Well, here you can run tons of Lambdas and they kind of does funnel the logs for you. So you're using CloudWatch. There are some nuances around there, but it does consolidate it. So that is a nice thing. So I don't know, there's pros and cons to some of that, across the board.
Yeah. And so there's another question about cold starts for Lambdas. I don't know if Justin, I guess I'll let you answer it, but is that a problem that we run across a lot, is the cold start?
It's gotten a lot better. AWS has been doing lots of work trying to minimize this as much as possible. So depending on if you're in a VPC or not, that has an impact, and the size of the Lambda has an impact. Potentially any other infrastructure it's using could potentially have an impact. But we, with the pipelines, we don't have too much of a problem with it. Those, and they're also running a lot. So usually when you invoke a Lambda, it goes into a kind of temporary state. And then if you invoke it again a second later, it's really quick because it's already been warmed up. After 15 minutes of no invocations, it'll then go cold again. So you only get it the first invocation, and, it's more of a problem if you get like lots of, like, go from 1 concurrency to 100 concurrency, because then you're saying, okay, now I need 100, and then you're going to have a cold start of potentially 100. But they do have options if depending on your tolerance for that cold start and how long it is based on the VPC and the size of the Lambda, you might find it, you go to reserve, or you go to provision concurrency. So you could say, okay, we're going to spend extra money and provision 100 of these. Then they're going to be right away. So you spend more to get that quick provision concurrency. But, honestly, we haven't had to do that for most of our services, because we do have some strategies for keeping at least a few Lambdas warm. It's a little bit of a hack. We just kind of ping them every once in a while. So at least those first random requests will be already warmed. So you can kind of play around with all those things and decide if it's worth the provision concurrency, because it does cost extra, or can you kind of get around it? Is the speed with the other optimizations fast enough? So it is something you have to play around with. But like the Lambda in this demo that's not on a VPC and it's hitting DynamoDB, I mean, it's pretty performant even when it's cold.
Yeah. And the only time that we've really done any of those kind of like cold start hacks is when it's like on a user interface, like, okay, I'm going to do a search for players. And it's like, well, the first time, and it's supposed to be really responsive, and, but if it's cold, it might feel a little broken. And so we'll like keep something like that warm. But any sort of data pipeline or API, like basically people don't notice the cold start. It's just not really.
Well, and then we have had some issues where over the course of time, they have changed a lot of their limits in AWS. So we used to bundle Lambdas, which are bigger payload size. So those Lambdas that we were mentioning here, they were big. They were 40, 60 megabytes zipped up. So that's going to start much slower than a, 300 kilobyte file that you upload. So, I mean, you could always feel free to test this out. It's blatantly obvious.
Awesome. I think we have another question. So how do you update a collection of Lambda functions on runtime? I don't know if you understand that question. Maybe a little more qualification might help, or.
Yeah, so, well, in the demo, there was a collection of Lambdas. So in the first service, the player service, we had 2 Lambdas. We had a Lambda for post, and we actually had a separate Lambda for get. So they might be able to be combined depending on how you want to design that, but there were 2 Lambdas. So when I ran SLS deploy, it actually did deploy those 2 Lambdas. And then in the second microservice, the stat service, that had 3 Lambdas. So again, when I ran SLS deploy, it actually deployed each one of those Lambdas. So the Lambdas in a microservice were all deployed when I ran SLS deploy there, when I deployed through the serverless framework. We do have other strategies to deploy multiple microservices at once. I was kind of alluding to, that's probably a whole other talk to orchestrate that, but there are strategies to do that as well. So if we have 36 microservices and we need to deploy a whole new instance, it would be tough to do each one manually. So we actually have utilities to say, okay, let's deploy the whole thing. And it's part of our deployment pipelines in production.
Did that help answer the question, or is there a follow-up on that? Cool. Awesome. Yeah, maybe there is a talk about orchestrating an enterprise application. So one of our applications that we're talking about, we have several of them that use this, is an analytics platform. And to Justin alluded to and showed a thing, it's like what 38 microservices, 10 different databases, a whole bunch of queues, a whole bunch of stuff. And then we're using step functions to orchestrate that. So if you basically needed an entirely new production stack with maybe like 5 steps, basically, and then 5 manual things that you need to do, the rest is all orchestrated through step functions and will completely deploy to a new AWS account. So, you can orchestrate this whole thing, and then using like cloud formation variables and some of those discovery things, that's how they're all connected. So there's, all this infrastructure as code is really important and part of all of this as well, I think. Cool. All right. Well, maybe if there aren't any, or if there are more questions, happy to keep taking them and keep talking serverless. That's what we're here for. So yeah, any other questions?
Is Sportradar hiring?
We are definitely hiring. Thanks, Luke. Yeah, if you're interested in what we're doing, on the tech stack side, definitely reach out. We're definitely hiring, and we got a whole bunch of this type of stuff sitting in front of us. And yeah. But also, definitely, really interested in, hearing from y'all as well. How many people are doing serverless at their work today? Maybe like a show of hands or something. Cool. So a few of us. Awesome. How many are interested in doing serverless? I mean, you're here, right? So, so awesome. Well, cool. So I think if you guys want, leave any feedback on the meetup group, any topics that you guys are interested in, leave them on the meetup group, and we'll try to figure out how to get the next kind of meetup going. Maybe if we need to, we'll keep seeding the group and do some of the stuff we're doing, but definitely want to hear people about what they're interested in, what aspects they're interested in. We'll do deep dives. Like the group says, it's serverless in real life. So we're going to do real life examples, code, that type of thing to really show it working, and talk about what it takes to build real software with serverless architecture. Thanks, everybody.
Yeah, thanks a lot.
Thank you.
Bye.